Friends, we are going to study our last section of chapter 3 dimension, the chapter 3 dimensional geometry. Okay, the plane. Okay, plane. So a plane is a surface such that if two points are taken in it, the straight line joining them lies inside the surface. Okay, so in a plane, if we join two points, that straight line, okay, joining the points, lies inside in the surface, then we can say it is a plane. It is a plane. Okay, and the general equation in three dimensional, because it is three dimensional, so there has been xy/z plane. So an equation of the form ax plus by plus cz plus d is equal to 0, where a, b, c are non-zero, okay, which is called the general equation of the first degree in xy/z. Okay, next, the general equation of the plane. So the first degree equation is ax plus by plus cz plus d is equal to 0, where a, b, c, d are non-zero, a, b, c are non-zero numbers and d is a constant. Okay, so then the general equation, what is the general equation? So the locus of this equation will be a plane. So it is a plane. So if every point of the line joining any two points on the locus lies on the locus. Locus means the surface. That surface is the plane here. And if we join two points, okay, in the on the locus, and every point lies in the on the that is inside the locus. Let P and Q be 2 points, where x1, y1, z1 is P and Q is x2, y2 is z2, and which is on the locus, and we can represent it as the equation ax plus by plus ez plus d is equal to 0. So P and Q are lie on that equation. We can say ax1 plus by1 plus ez1 plus d is equal to 0, and ax2 plus by2 plus ez2 plus d is equal to 0. And here we have just multiplying the equation by k and adding it by 2. You will get, yes, coordinates, 3 coordinates, which is also on the locus, that is x1 plus k x2 by 1 plus k, y1 plus k y2 by 1 plus k, and z1 plus k z2 by 1 plus k. These are the 3 coordinates. Okay, this shows that this points also lies on, yes, locus. But for different values of k, these are the general coordinates of any point on the line PQ. Okay, any line on the PQ, this is the general general coordinates. And if we change k, as k changes, the point also changes. So every point on the straight line joining to arbitrary points on the locus lies on the locus. So by definition of a plane, it is on the, yes, that plane, that locus is a plane. So the general equation of the first degree also represents a plane. Okay, yes. Then here the number of constant in ax plus by plus cz plus d is equal to 0. Okay, which can be a by d, b by d, c by d plus 1 is equal to 0, or a1x plus b1y plus c1z plus c equal to 0. That is, a1 is a by d, b1 is b by d, c1 is c by d. Okay, this shows that equations contains 4 constants a, b, c, d, and yet in reality it has 3 independent constants. Oh, this is just a note. Okay, next is the important one point form of the equation of a plane. 1 point form. Okay, 1 point form. So equation a point is given, we know the sorry okay, one point is given, x1 y1 z1, and a plane is given. You know the equation of the plane, ax plus by plus cz plus d is equal to 0, which is a first degree equation. Okay, and since x1 y1 z1 lies on it, okay, and then we can say ax1 plus by1 plus cz1 plus d is equal to 0. So we get two equations, and then subtracting 2 from 1, but we will get, yes, a into x1 minus x plus b into y minus y1 c into z minus z1 equal to 0. Okay, so which is the required equation of the line passing through a given point. So if we have given a point, how will you find the equation passing through that, passing through the plane, equation of the plane passing through that point? Okay, this is the equation. If you have given a point, okay, given a point, and you know the equation of a plane, ax1 ax plus by plus cz equal plus d is equal to 0. So if you have given an equation, how will you find the, yes, equation of the plane? Okay, this equation is used, a into x minus x1 plus b into y minus y1 plus c into z minus z1 equal to 0. Okay, yes. Okay, and in order to find the equation of plane passing through three given points, if you have given 3 points, x1 y1 z1, x2 y2 z2, and x3 y3 z3, you can use this, yes, the following method. What the you have given 3 points, okay, and there has been 3 equation, yes, and then that 3 equations, the coefficients of a, b, and c, coefficients of a, b, and c can be, yes, written as a determinant form, and which is equal to 0. Okay, so you can find the determinant value, then that is the equation of the line passing through. Okay, determinant x1 y1 is, x minus x1 y minus y1 z minus z1, x2 minus x1 y2 minus y1 z2 minus z1, x3 minus x1 y3 minus y1 z3 minus z1. Okay, this is the equation. So if you have given 3 points, this method is used to find the equation of a plane. Okay, and then next is find the equation of a plane through 3 given points. That equation is given, question is given. How will you find the equation of the plane passing through 3 points? Minus 2 6 minus 6, minus 3 10 minus 9, minus 5 0 minus 6. Okay, there. Okay, look at that. The determinant, yes, has been found out, and find the determinant value. You will get the answer. Okay, and another method has been given. Yes, equation of plane passing through the point minus 2 6 minus 6 is a into x1. That equation has been given, and since it's passed through minus 3 10 minus 9 minus 5 0 minus 6, we can equate it, then you can find the values. Okay, that is by cross multiplication. Yes, we can find a by minus 2, b by 1, and c by 2. Okay, and substitute these values in first equation, you will get the required equation. Okay, and proving 4 points a coplanar. You have find what is a coplanar. How will you yes, that is how will you show that 4 points are coplanar? For that also, yes, 4 points has been given. Take the first 3 points and find out the equation. Okay, equation of the plane, find out the equation, and hence the fourth, yes, you can, fourth point is lie, then you can know, you can find that the fourth point satisfies the equation. Okay, and next is the most important part of this chapter, normal form of the equation of a plane. Yes, we have studied the 1 point form. Next is the normal form. To find the equation of a plane in terms of P, the length of the normal from the origin to it, and LMN, which are the direction ratios of the normal. Okay, so what is normal? Normal is the length, so that means P is the length of the normal from the origin to it means that point, that plane. Okay, and the equation is Lx plus My plus Nz is equal to P. Okay, Lx plus My plus Nz is equal to P. L, M, N are direction ratios, and P is the length of the normal from the origin to it. Okay, and the just a proof is given. ABC is a given plane OM with a normal, and which is from the origin to the plane, and OM, the direction cosines of OM are cos alpha, cos beta, cos gamma, which is L, M and N, and OM is equal to P, and coordinates are P cos alpha, P cos beta, P cos gamma, that is LP, MP and NP. Okay, and the corresponding direction ratios are perpendicular to M, and that means direction cosines of MP, which is MP, yes, MP is also proportional to the point. If XYZ be a point, P, capital P is a point, and then you can find the equation Lx plus My plus Nz is equal to P. Okay, which is the required equation of the plane, and being the locus of P. Okay, this is the most important point of the most important equation, normal form of the equation of the plane. Next is the intersection of a line and a plane. We have studied the equation of a line in the previous class. Now what is the intersection of a plane and a line? Okay, to find which is a point is given, and the point of intersection of the line is x minus 2 by 3 equal to y plus 1 by 4 equal to z minus 2 by 12, with the plane x minus y plus z equal to 5. So x minus 2 by 3 is equal to y plus 1 by 4 is equal to z minus 2 by 12, which is the equation of the straight line, Cartesian equation. Okay, and x minus y plus z is equal to 5 is the equation of a plane, and the point is given, point. Okay, and how will you find it? Yes, the line intersect the given plane in the point P. So you have to find the coordinates of any point are x minus 2, that equation which is equal to r, that is 3r plus 2, 4r plus r minus 1, 12r plus 2. That is the coordinate, where r is a arbitrary number. Look at that figure. Yes, the point and the line and the plane is given. Okay, and if it lies on the plane, that line is lie on a plane. So x minus y plus z equal to 5. That is the x value is 3r plus 2 minus y is 4r minus 1, and yes, you will get r. What is r? R is 0. So the point is 2 minus 1, 2. That is the point lies on the given line and the plane. Okay, and the required distance is the distance from minus 1, 5, minus 10, and 2 minus 1, 2. So find the yes. What is the answer? 13. So 13 is the distance between. Okay, that is the intersection of a line and a plane. Okay, and next is the intercept form of the equation. Intercept form. Yes. To find the equation of the line which cut off intercepts A, B and C respectively on the axis x, y and z. You know what is an intercept? Okay, you have studied. And if that intercept cut off, A, B, C intercepts cut off the lines, the axis A, x, y and z. What is the equation? X by A plus y by B plus z by C is equal to 1. That is the intercept form of the equation of the line. Okay, and how will it get, that is given in the figure and description also. Okay, this is the required intercept form. This is to be studied. And to reduce the general equation means ax plus by plus c z plus d is equal to 0. How will you reduce it into the intercept form? That is, you can write, yes, you can just rearrange that equation by changing that constant to the other side minus d and dividing that that is intercept to become 1. Okay, intercept to become 1 and a by minus d into x, that is b by minus d in plus y, sorry, a by minus d x plus b by minus d y plus c by minus d z equal to 1. That is the intercept form. And then the coefficient of x should be 1 for so that we can divide it by minus d by a. So it becomes x by minus d by a plus y by minus d by b plus z by minus d by c. That is equal to 1. So the intercept form should be, yes, two things you have to remember. The coefficient of x should be 1 and it is equal to 1. X by a plus y by b plus z by c is equal to 1. Okay, these two things are the main points for our intercept form. And now the exercises. Okay, yes, the normal, to find the normals and intercept and also equation of the plane. Yes, okay, that is the okay. And yes, the next is vector equation of a plane in the normal form. Okay, we have studied the normal form, and how will you find the vector equation? Vector equation is, yes, you have to know the vector means you have to find the vector. This has magnitude, so the direction should be given. So r, vector r dot n cap is equal to p. That is the vector equation for the in the normal form. Sorry, vector equation of a plane in the normal form is vector r dot n cap equal to p. Okay, what is, yes, what is vector vector r is given. Vector r is the given vector, n cap is the normal, and p is the, yes, sorry, n cap is the unit vector and p is the length of the normal. Okay, n cap is the unit vector normal to the plane. Okay, according to that figure, this is the normal form for the perpendicular or the perpendicular form. And some notes has been given. If the equation r vector r dot n cap equal to p, which is the standard form of the equation, where is what is r? Vector r is the position vector of any point of the plane. Okay, r is the position vector. Okay, you have know what is the position vector. So vector r is the position vector, n cap is the unit vector perpendicular to the normal, and p is the distance of the plane from the origin. That is the normal. Okay, that is the one. And if the line passes through p is equal to 0, that means through the origin, what is the equation? Okay, what is the equation? Yes, r cap, vector r dot n cap equal to 0. And the Cartesian equation is Lx plus my plus nz equal to 0. Okay. Yes. Next is the plane through a given point. To the equation to find equation of a plane through a given point perpendicular to given vector. Vector form is vector r minus vector a dot n, vector n is equal to 0, where vector r is the, yes, what is vector r is the position vector of any arbitrary point p. Okay, and vector a is the position vector of a given point capital A, and n, vector n is the normal. Okay, normal of to the plane. Then you have to find the dot product. If the dot product is 0, then the plane, yes, the plane is through the given point and the perpendicular. Okay, I think yes, and that is the scalar product form. You know, it is the dot product, so it is a scalar product form. And that is the Cartesian reduction to the Cartesian form. That is a into x minus x1 plus b into y minus y1 plus c into z minus z1 is equal to 0. This is the Cartesian form of the equation. Yes. Okay. that is n, the n vector n has been written in the vector form, and a x1 y1 z1 b p x y z, that equation has been substituted, that is a into x minus x1 b into y minus y1 and c into z minus z1 is equal to 0. And some notes has been given. If that r vector r dot ai plus bj plus ck is lambda, then we can conclude that the vector is normal to the plane. And if abc represent the direction ratios to the normal, the Cartesian equations to in the Cartesian equation, abc become the direction ratios of the normal. And then yes, if the length of the perpendicular from the origin to the line is r vector r minus a vector r minus vector a dot vector n is equal to 0, then vector r dot n is equal to d is modulus of vector r dot vector n by vector n. That is also studied in your, yes. Okay, so this is for the chapter 3-dimensional geometry. We have completed the chapter. Please what you have to do is please study all the equations, okay, all the intercept form, normal form, Cartesian equation, vector equation, scalar product, vector product, okay, all that. Okay, according to these equation, according to this, questions has been asked. Only textbook questions has been will be asked for the exam. So study very well and do all the exercise problems. Okay, thank you, students.